All of you, my screen is visible. Anybody? Hello? Hello, anybody? My screen is visible.
Yes, sir.
Okay. Okay, we'll start today. KNN algorithm or K nearest neighbor. This is one of the technique in supervised learning algorithm to find or to predict your new data set. Previously also in the previous class we discussed naive Bayes classifier, and before that we discussed support vector machine. Like that we have another technique. This is a k nearest neighbor. It is a very lazy algorithm, not that much efficient, but still there is a method is there to find or to predict your new data set. And this is also, as I mentioned, the type of supervised learning algorithm. Again, it will be used for regression as well as the classification problem. Predict the correct class. You may have class 1, class 2, and if new data comes, it is related to which class it has to predict. That is what KNN will do. What in that process, we have to find the distance between the test data and all other training data points. We are measuring the distance here. Here K we have to select whether K is 5 or 4 or 3 or something, depends on your accuracy you can select, but preferably for that also there is a lot of methods are there to select the K, but in our case generally we will fix any value of K and we are finding the or we are predicting the data. K number point which is closest to the test point, that class we are deciding. So in any case the points may be here something these points, and this side maybe some other points, let us assume that. Mm, yeah, here maybe something points maybe here and something like that. And if new data comes, let it be the new data point maybe something like this. The question is this data point, whatever already available in this side and that side, this data point is related to this class or related to this class. That is only our question, nothing else. So already existing data is categorized like in hyperplane and all we discussed in the support vector machine. There we categorized one line and other side, one side is one classification, mm, line above or below or something like that, left side, right side or something. And that will be other classification. That is in the case of support vector machine. In iBias also, if new class comes, we have to identify, or new data point comes, we need to identify the class, whether it is what based on the target. A target may have two classes, yes or no, or one or zero or something, or maybe some names or something else. Based on that classes, we have to identify. Similarly, now also in k nearest neighbor case also, what we'll do is, if new data point comes, we need to assign or we need to identify the data point is belongs to class 1 or a class 2 like that. Probability of test data belonging to the class of K training data, and the class that holds the highest probability will be selected. So now if the data point is very near to that any class, or if K is 2, 3, 4, and so on, the majority. If K is 1, the target may be one class. K is 2, the target may be other class. K is 3, the target may be again first class, like that. Based on the K, if the majority votes come for class 1 or class 2 or classification 1 and classification 2, based on that it will assign the new data point. This regression, normally we are dealing with classification. in the case of regression, what will happen? Mean of k selected the training point. That is the another way while we are using as a regression problems. Now we are doing as a classification problem. This unit consisting of only two categories. One is the classification, another one is the regression. In classification, as per our syllabus, we divided as a naive Bayes and then k nearest neighbor, decision tree, and then support vector machine like that. Similar fashion, we'll go for as a regression, logical regression, logistic regression, linear regression, like that. We have some more methods. We will discuss that in the regression case. New cases or data are available cases and put the new case into the category that most similar to available category. Like as I mentioned, these points are available if new data point comes based on the nearest neighbor. If this data point is near to this, we'll assign the new data point is to this, or the new data point near to this, we'll assign here like that. That is only our thing. Now we'll see. This is why I call it as lazy algorithm also we tell. What it will do is store all the available data, classifies a new data point based on the similarity. Whatever data point features are available, it has to store the data features, and based on the new data, it has to assign. When the new data appears, it can easily classify it into suitable category, either of the class. There is for regression as for the classification, but mostly used for the classification. As I mentioned in the previous slide also, the KNN, support vector machine, and the naive Bayes, these are all some of the algorithms used for regression as well as the classification. But most of the case will use it for the classification purpose. It does not make any assumptions or underlying data. So see, without any assumptions, it is going to be solve the problem. That's why we call it as a non-parametric algorithm. It is also lazy learning algorithm. It does not learn from the training set. This is the major drawback actually. Normally, what algorithms will do, we are dividing the data set into categories, training set, and then test set and all. What algorithm models, or you can say that machine learning models, will train the data from the past data, and it will train. And if new data comes, we can able to assign this data to any of the category. But what we can do is it does not learn from the training set. Instead of it stores the data, and at the time of classification, based on the new data set, it will check with the available data, the features which is near to, suppose dog and cat is there. What it will do is it will store the features of dog and all features of dog and features of cat, like that many images data it is stored. And once new data comes, it will check with that features and it will assign the category. And KNN algorithm or the training phase just stores data. Here, we will not do as per the sentence you can see. It will not train the data from the training set. It will store instead of that, it will store the data. And when it gets new data, and it classifies that into category similar to the new data. This now we can see here, there is a KNN classifier. The input value is one thing and predicted is output. In that, what it will do, example, we have an image of looks similar to cat and dog. Now you can see, because the KNN classifier is already available a lot of images related to the cat and dog. Because instead of training the model, what we'll do is it will store the data, cat data, dog data, like that, different kind of features. It will store the data. It is by seeing it will be bit similar. Now we want to know if new data comes, This will compare the existing store data and it will predict the output. Now what we'll do is works on the similarity measures. So now it will check the similarity or features with the existing data, and our model is find the similar feature of the new data set to cast and docs images based on the most similar feature will be put into the category. Either in final prediction, it will be decided whether it will be as a cat or a dog. Now we can see another example like before KNN, we have as a data point, let it be two categories, category A and category B. In category A, we have some data points. Category B, that one, and category A also, we have some data point. This is what already decided. Now, some new point comes, a new person comes. It based on his features, we are to decide is belongs to category A or belongs to category B. That is what the new point is this one. Now, once if you apply the KNN to this, what it will do is normally. So in this case, is mentioned it is belongs to category 1. How this is going to be done? That is only our problem. Today's problem is K nearest neighbor. We have to identify nearest distance between this, and this, and so on. Nearest points we have to identify, and we have to find the distances, and based on the distance you can give the rank, which is minimum distance we allocate as a rank 1. Suppose for this point we want to calculate. We know x1, x2 here. You know x1, x2 for this point, and 2 points. Between the 2 points we can easily identify the distance, or you can go for as a formula, Euclid distance formula. Now, by seeing this, it is near to the category A. Now we are assigning this to be category A. That's what there are, whatever I explained so far. Category A and category B, we have new data points, X1 and X2. The data point will lie in which this category is our question. Now, this is what already available, the new data point arrives. Now we have to identify it goes to category 1 or a category 2. So how to solve this? So you have to go for as a KNN algorithm, which helps to find KNN. We can easily identify the category or a class, particular set means new set. Now that blue color set we have to decide. As per the distance by physical observation, we can assign, but normally we have methods, Euclid distance method is there. We have to use the formula x1, x2 or x3, x4. Based on that formula, we have to find the distance between the 2 points. So for that, there is a KNN works with some algorithm. In that, select the number of k of the neighbors. So here k is a KNN. It will be 3NN, 2NN, 5NN, something like that. It is a number of neighbors. So the algorithm, some of the algorithms normally in optimization algorithms and all, what we have in the optimization algorithm, we are selecting as a random, and then we are putting into function, and we have to check the function value minimum or not based on the minimization function and all. Now here we can select the number k of the neighbors. So here the k is a selection. K may be 1 or 2 or 3, something like that. As I mentioned, k, a selection of k itself, we have different techniques. You can use the technique, but in our case, we are not using the technique. Normally, we are assigning k is equal to 2 or 3 or something. Calculate the equidistance of k number of neighbors. So now 3 neighbors are there. In that, you can see here this point. Suppose this is the 1k, this is another k. This may be something. and we have to find the distance. This is x1, x2. This is x1 and x2. Then I mean x1, y1, x2, y2, like that. We can go for as a Euclid distance formula. X2 minus x1 whole square plus y2 minus y1 whole square. Using that formula, you can able to find the distance between the 2 points. Now, that's what here third step is nearest neighbor as per the calculated Euclid distance. For that, we have to use the formula. Among these, the nearest neighbors, count the number of data points is each category. So suppose category 1 may be 2, category 2 may be 1, then majority the new point is belongs to category 1, like that. Assign the new data point to the category for which the number of the neighbors is maximum. So and our model is ready. Once model is ready, we have a new data point. We need to put into the required category. Consider the below image. Now we can see there is a Euclid distance formula. We can see x2 minus x1 whole square plus y2 minus y1 whole square. There is a 2 points. One is a this point, other is this point, because we are to measure the distance between the new data point to nearest neighbor points, and you calculate such a way that which point is giving as a nearest point that you can assign as a rank 1. Like that, if you do all other point, that is one way. This is the preferably will use as equidistance point, distance between the 2 points. D of x comma y means this is x point, maybe this is a y point. We have to calculate the distance between x comma y. X1 minus y1 whole square plus x2 y2 whole square, like that. Whatever formula we already using for distance measurement, you can use that formula as a distance or Euclid distance. In other methods, we may have, and there is a Manhattan and then Minkowski distance. These are the, there is a different kind of formulas are there to measure the distance between 2 points. So which one is preferred? Sometimes in exam itself, they may ask, use this distance formula and find the location. So similar way, we have to find the distances. Formula is these two are the distance formula. In that, you choose the number of neighbors. So there is a k is 5 that I can. Suppose in our case, normally, while you are calculating small problems and all, because total data set itself as a 5 or 10 or something like that. For that reason, we'll take it as a k is 2 or 3. First 3 ranks, they may be belongs to any target. We can assign the data. Now these are the 4 methods we have: Euclid distance and Manhattan, and then Minkowski distance. These are the, instead of using this formula, we can use this formula. And Euclid distance is the distance between the 2 points, which we are already discussed in previous, are calculated using this formula. And another one we can see here, by calculating equidistance, we got the nearest neighbors of 3 nearest neighbors. Now we identified that this is the 2 categories B, and these are the 3 categories of A. Now based on the distance, we can observe that majority, these 2 are in the category A and this is the category B. In that context, I can say that there is a, from category A, the new data point must belong to category A because it is a majority. It goes to category A. Like that, we have a lot of problems we need to solve. Like yesterday, what we did naive Bayes algorithm and all. In the k nearest neighbor also, we have to solve the data set they may give, and the new data set or new data point will arise, and we have to categorize that case. How do I select the value of k? So this is what I mentioned earlier. There is no particular way to determine the best value of k in this case, but we have the methods or techniques to find the k as well. So what we try to find the best solution as per k is 2 or 3 or 5 something we decide. Most preferably, we'll take it as a k is 5, but very low value of k, let it be k is 1 and 2, then what will happen? The noisy data will arise and lead to the effects of output in normal. So this is the way of k and k value. So k value we can decide preferably 5. A very low value will give noise and leads to the outlier of the model, that is effect will be there if it is very low value of k, and large value of k are good, but it is very difficulties are there. And you can see some advantages. It is a simple to implement, robust to the noisy training data, and be more efficient. It will be training data is large. And disadvantage you can see. So always need to determine the value of k, which by complex sometimes because every time every data point, new data point with respect to the existing data points we need to calculate. For all the data points we need to calculate. After that what we'll do is we'll give the rankings, and the rank 1 is belongs to which category, we'll assign the new data to this if k is equal to 1. If k is equal to 2, rank 2 also consider, and which one is the maybe more or less same may give the result if k is equal to 2, and category 1 and category 2 may not be will be the same, but it must be required any class based on the features. Now we'll go for example. It is read the problem. It is very quite simple. The question is you have to use KNN classifier. The length is given, that is what sepal length, sepal width is given. Then species we have to identify whether it is a Setosa or Virginica. These are the two categories is mentioned. So I mean 3 also will yeah, this is the two category Virginica, and then this is also their versicolor, and then Setosa. So these are the 3 classes are there based on what they already have the data. Uh, sepal length is 5.3 and then sepal width is 3.7. That is belongs to a Setosa. Similarly, 7.2 and 3 it is a Virginica. Like that, we have a lot of data set. But at moment, we see the given table because in exam point of view, we require the less data set only. If we are going to write a programming, then we can decide we have to take the lakhs of data sets also, existing data point, 2-year data, 3-year data for the other purpose of energy and all. For normal, any data you can take it, we'll consider as a large data, and then we can, what we can do is we have to identify what we can able to find the new data. Now the question is, where is the new data set? Now this is the situation is already known to you. If weight, I mean length is this much, width is this much, it is belongs to this, or this belongs to this, like that we have. Now the question is like this, they are asking. We have to identify. The problem is this one. What is the problem is mentioned? Given to you with length is this much, width is this much, then what is your answer? Means the output or a target. This is what you need to identify the output or a target. Now the question you can see, we cannot guess directly. 5.2 is length. Anywhere it is there 5.2, we don't have this length. And the width is 3.1. Here may not be available 3.1. Then similarly, this is the length and this is the width or something like this. we are able to find out the category. This may be this or anything we are able to find. Now new question comes based on the existing data. And if new data comes, the question is asking 5.2 length and width is 3.1, then it is belongs to what species? That is a Sitosa or Virginica or any for that, not only three, it may come later point of time, something like this also. In that we have to identify. Now, as per our previous discussion, first we one new point comes, we have to find the distance using what formula. In problem they may specify any distance method. As I shown you, three formulas are there for different kind of distances. Any one you can use it, but intention is simple way we can go for as a Euclid distance formula. Now how to find a distance? Now we can make here is a distance is a one column. We have to fill this table with new data to each data point using Euclid distance formula. What is Euclid distance formula? X2 minus x1 whole square plus y2 minus y1 whole square root. This is the formula. Now you know what is x1 and x2. Let us do that. So this is the new data point. This is the present data point. This I call it as a x1 is 5.3 and another point is x y1 is a 3.7. This is one or x1 x2 anything. Any notation you can follow, distance between two formula. This is one point. Another point is here is mentioned 5.2 comma 3.1. Now the formula distance is, what is the x2? 5.2 minus 5.3 whole square. Because it is a whole square, you can use x1 minus x2 or x2 minus x1. Anything is same because it is a squaring. No, we don't get any different answer. And this is a 3.1 minus 3.7 whole square root. This is the first case distance. Now that value you can fill it here. And other distance, this distance, new data to second point, because a lot of points are available. No, these are the points are available in the different categories and this categories, and new data comes here, and this point to measure the distances to other points like that. And similarly, what is the second data? This is the available data with new data. Then whether you will get it classified which one. That's what we need. Now for that, using that formula, I calculated the distance. What is the distance I calculated? You can see as I mentioned, new data 5.2 minus this row data 5.3 whole square and then 3.1 minus 3.7 whole square, you will get 0.608. That I mentioned here. That means either just for understanding I run separately. Here you make a column, one column. You can add the distance point is difference between the new data set and existing new data point and existing data point. Similarly, how we can calculate this one? Same formula, this formula only. You can see root of, what is this formula? 5.2 is the new minus 5.1 whole square and plus 3.1 minus 3.8 whole square, and that is equal to 0.7. Similarly, third 7.2. What you can do? 5.2 minus 7.2 whole square. For third one I am telling, and plus 3.1 minus 3 whole square root. That will be this value. Like that, you have to fill. It is very simple, but it is more calculation, waste of time and all these things. So now like that, we calculated all the distances. That is the one step completed. What is next step? We have to give the ranking based on the minimum distance will be the first rank and so on so forth. Like that, we have to represent the what you call it as ranking. Now, same, which one is a less, that will be treated as a rank one. This is 0.6 and then 0.3, 0.2. Maybe this is 0.2, anything is there. Yeah, this may be rank one. Like that, we will get the ranks. So based on that, if k is equal to 1, now K is 1 means first rank is related to what? Sitosa. So now if the length is this much, width is this much, then species name is a Sitosa. Like that we have to calculate. For that you can see I mentioned the distances using equidistance point. After that we'll go for as a ranking. The ranking, which one is having as a less, that will be given as a rank one. You can see this is rank one, and then second rank, yeah, 0.3 second rank, third rank, and then yeah, fourth, like that you have to fill. Now the question is, if k is equal to 1, straight away I can decide new data point is related to Sitosa. That is a k is equal to 1. I can write this new data point species we categorized is a Sitosa. And then if k is 2, then what will happen? What is your answer? K is 2 means 1 is Sitosa, second rank you can see also Sitosa. Then K is 3, 3, first 3 you have to take it, nothing else, first 3 ranks. And K is 3, also Sitosa. Then K is 4, what is 4? Let it be different. Yeah. Vesicolor. So 4 is vesicolor. Now the question is, if I take, let it be 5 also, you can take it, Virginia. Now what is your answer? Finally, k is equal to 5. Then your answer is, let it be Virginica. So what is your final prediction? If k is 1, 2, of course 3, also Sitosa is giving. K is 4 is one other species name is telling. K is 5 is another one is telling. Now how to conclude your prediction? So what is your prediction? Here you have to write what is your answer. So if length is 5.2 and width is 3.1, then what is your answer here? Here we can write the final answer. What is the majority? If k is equal to 1, 2, 3, same, we call it as Sitosa, and 4 is one category, 5 is another category. Therefore, majority is showing as a 3, k is 1, 2, 3, all showing as a Sitosa. Then your answer is a Sitosa. That's all. So like that, we have to solve the problem. And that's what I mentioned. K is 1. It is showing Sitosa. K is 2 also Sitosa. And then if K is 4 and 5, and based on this data, we can able to identify what is the majority class. This is your majority, and hence we can say that new example is related to Sitosa. Similarly, another problem you can see. What is this problem? We have to identify, very simple by sense you can see, height in centimeters, weight in kgs, they mention. And class is what? I'm audible, anybody? There is a power loss. I'm audible, ma? Anyone can
Yes,
respond?
sir.
Yes, sir.
Yeah,
Yes, sir.
just 1 minute power loss. That's only. Okay, now we can see k nearest neighbor. Again, the another question. The question is what here? Available data based on the available data. Height is 167, weight is 50 by 51. Then we can say that underweight. And if height is 182, weight is 62, it is a normal. Like that, they categorized whether it is underweight or a normal weight. Two categories are there. The new question comes. 170 is height, then weight is 57. This data set is not available in the present one. There is a new data point. Now we need to say whether it is a normal or a underweight. So when we can say normal, as per the given data, you can see that 170 height, but weight is 55, I can say normal. But if it is a 57, we don't have match this data. But if 57 weight is there means height is only 173. There, 173 height. But now height is 170, weight is 57. Now we have to give the answer using KNN algorithm. Exactly same. First step, what you have to do? Only 3 steps, very simple problem. First step, you have to find the equidistance formula, new data set, and for each data point, you have to calculate. How will you calculate? New data set is 170 height, and then 167 whole square, and plus 57 minus 51 whole square root. Like this, we have to calculate the each value, means new data to this and new data to second one, new data to third one, and so on. You have to calculate the first distance, and then we will give the rank. After that, you can decide whether it is underweight or a normal. That's what you can see. The equidistance formula is this one. Either you can use any formula, x1 minus x2 whole square also fine, because it is a squaring, no, it will not get any issue. Now I did here 2 cases and rest will be simply filled here. What is the distance one? 170 minus 167 whole square, then 57 minus 51 whole square, will get distance is 6.7. Then for second row, what will do? 170 minus 182, then 57 minus 62 whole square, that distance is a 13. Now we got it as a 13. And third one you can see 170 minus 176, 57 minus 69, we got the distances. Now, first step is over. What is next step? We have to give the rank. Now I'm giving as a rank. How to decide the rank? Which one the distance is very minimum? That is rank 1. Or you can say that that new data point is related to that class. That's it. Near means that category. Now the rank 1, 2, 3, 4, and so on, we got it rank. Now tell me the suppose k is equal to 1. What is your yeah? So k is 1. What will happen? 1 is related to normal class, no? That's why your answer is normal here. If k is 1. If k is 2 also normal, k is 3 also normal. And if I take k is equal to 5, what will happen? If k is 5, it is showing as a underweight. But what we can do, whatever may be the k, based on the count, how many normals and how many underweight, based on the k value, and you can decide your final answer. Now, your final answer is based on the K value or majority, or you can say. So majority in the sense based on the K only. K is 5 means first 5 you take it, and in that majority you will consider. That's what I mentioned. I sorted, even if you not sort also, you simply mention the numbering and which one is having rank 1, that class is your final answer. Or if K is 3 or 4, so based on the majority, you can decide. That's what predict the new instant based on the K value. In this example, K will be given to you. Let it be 5. Let assume that based on the K, majority of the classes will be the final answer. So now finally it will be as a normal 170 height and weight is 57. Then your class is going to be as a normal. This is second one. Now you see third one. Now anyone can guess how to do this problem, because earlier it is a number, numericals. Distance you can easily calculate by subtracting using Euclid distance formula. But now anybody, what is the question is here? Suppose if you go for a restaurant, and then there is a different flavors are there, and based on this flavor, let it be pepper. You want pepper or not, and ginger, and then chili. Then if the burger or something, anything you want to prepare, if you use this category, will you like or not? This is your output category. This is a output or a target. Now, based on the people interest, they store their information like this. Then person A, B, C, there is some data is available. If new data point comes, whether that combination will like or not, that's what our intention. In this case, again, what Euclid distance means, either a new data point will find the distance between new data to the first person and second person, third person, and so on. We can, if it is in numbers, but now it is a something feature, true or false or something. Now the new data point you can see pepper is false, means not there in that pepper, and ginger is true, it is there. Chili is true. Then whether that guy, the new person, will likes this item or not, something like that. Then that's what I mentioned here. Every day this week you have tried a burger. Some 6 members are, let it be 5. How many? 4, 5. So there is a to E. 5 members are there, and take the record whether they liked or not with different combinations. And using, there is a Hamming distance. This is a another method you are using, and 3 NN means K is equal to 3 I taken, and final answer is a prediction. So what is your prediction? Whether this combination in the burger consisting of pepper is not there, and ginger is there, and chili also there, then whether this person likes this burger or not. That is only the question. Now, how to solve this question? You have to go for as a Hamming distance. Here, the Hamming distance is very simple. No calculation by sense. Suppose this is the new data. No, in the new data, pepper is false. In the old data, I want to compare with first person. New data, pepper is false, and another one is ginger is true. Then chili is true. Now, how to use the Hamming distance? That's what Hamming distance. Using this new data. This one is a new data with the old. Again, same manner you have to find the distance. Here you can write one column. You have to find the distance between these two. So this new data to first person data, what is the distance, and second person, like that. The distance is very simple. If both are same, then we make it as a distance is 0. If both is different, then make it as a distance is 1, like that. So now what will happen? Pepper, there is a true and here is a false. Then what is the distance? Here you find the distance here. The distance is for this case is 1 plus, what is the other case? Ginger. Here is true, here is true. So ginger distance is 0 plus, then chili, true, true, then 0. Like that, you now the total distance is 1. And here you can see next with B. Both are different. You can see that this is true, this is false, then make it as a 1 and plus false and here true, then 1 distance and then false, true, 1 distance. Then this is a 3. Like that, you find the distance. This we can use as a, call it as a, what the name is, Hamming distance. Use that. Very simple logic, as I mentioned. This is the available data set. And new data question comes, and we have to finally whether he will like this item or not. That's what we need to identify. For that, whatever I mentioned, that's what the theory part I wrote. No, if x1 is blue, x2 is blue, then distance is 0. If it is different, one is blue, another one is red, then the distance is 1. Like that, whether true or false or 0 or 1, anything, different categories. If both the same category, I can say distance is 0. If it is different, distance is 1. That's what we are writing here. Final sentence are same thing. Both instances are the same, then the distance is 0, else distance is 1. That's it. That's what I calculated here. You can see, as I already explained, this is a false. This one is true. That way it will getting 1. Here is true. Here is true. Then distance is 0. And here is true. And here is true. Then distance is 0. Then total distance is 1. Similarly, second guy, the new data point with second. Then if similar, then we'll get it as a 0. If not, make it as a 1. Like that, we find the distances. That's the same thing I mentioned. Then what you have to do is K3NN they asked. K is already mentioned. K is 3 because 3NN means K is 3. So KNN algorithm 3NN means K is 3. So now first give the ranking. Something, this is a rank. Who is will get the best rank because the distance is 0. This is the first rank. Here the distance is 1 and here also distance is 1. So then the rank will be 2. So anyhow these two will be come into the picture and also rank 1 because total K is 3. We have to count 3 categories. So means in the sense 3 answers, rank 1, rank 2 and rank 2 times got it. That's why these 3 we can count. So now what is your answer? K is 1, whether he liked or not. No, he will not like. And K is 2 will not like. So K is 3, he will like. Then what is your answer? Final answer. Anybody? How can I find the final answer now? With this combination, whether the new customer will like or not. Because one is a false, is not like. Second guy, as per this K is 2, is also false. And K is another, you can see 2 only, but it is true. Then your answer is false only. The reason is majority. Majority here among 3, 2 will be the false. Then therefore your answer is false. That's what I mentioned. Based on the majority classes, false is your answer. So finally, in this example, I consider as a false. Now we can see fourth one. Like that, I have given many problems. Later also you can go through, but I will cover maximum extent. The training instant 1, 2, 3, 4 is there. Then x1 point is given, x2 is given, the output is 0. Now we can see that. So 7, 7 means output is 0. 7, 4 is output is 0. And 3, 4 is output is 1. 1, 4 is output is 1. Now again say new data point comes. You have to identify what is the output, either 0 or a 1. The question is same. Now the new data point is 3, 7. Earlier 7, 7 you have the answer. 3, 4 you have the answer. 7, 4 you have. 1, 4 you have. Now we have to find 3, 7 is your new data point. What is your output? Let consider k is equal to 3 in that case. So now again, equidistance formula, you can use it. Equidistance formula. As per new data set is 3, 7. I already mentioned either I can use 3 minus 7 whole square plus 7 minus 7 whole square root, or 7 minus 3 whole square plus 7 minus 7 whole square. Anything is correct because it is a square root. Now we got the distance is 4 and second category distance is 5 and then third distance is 3 and then last one distance is 3.6. Now what we are able to find here, the ranking, which is having least distance, you give the rank 1. So neighbor ranking, which is near to that. So let it be, this is rank 1, rank 2, rank 3. We got it, 3 ranks. So in the 3 rank, what is our output? The first one is 1, second one is also 1, third one is 0. Then what is our answer? Because majority, based on the majority, your answer is 1. So if training instant 3 comma 7, then your answer is 1. So like that, we can able to identify. And another distance and weights, we can able to identify this. Just a minute. Yeah. So now there is another way also you can able to find this category. The formula is distance and weights. The computing 3 nearest neighbors, 3, 7 is our Euclid distance and then corresponding weights. This is the distance value and d square you can give it. And what is the majority or probability? We can say that 1 by 16. This is 1 by 25. This is a 9, 1 by 9, and then this fourth one we call it as a 1 by 12.36. This is your votes, you can say. Again, based on the vote, we can able to divide your ranking. This way also you can find, but answer must be the same. Anyhow, the answer is 1. Similarly, another problem we can say, what is this problem is k nearest neighbor, example 5, BMI, age and sugar. So based on this data, the new data point comes with age is 70 and BMI may be something 42, whether he's having sugar or not. That's it. This problem you can do it. It's simple. Equidistance again you can use it. That's what I mentioned. Apply k nearest neighbor classifier to predict the diabetic patient or not. Assume k is equal to 3. New data point is like this. 43.6 is BMI. Then age is 40. Whether he will attack sugar or not. Based on this data. Now what you will do? Again you find the distance. Again give the ranking and k is 3. First 3 a majority, whether it will get the sugar or not. If majority is not getting sugar, then you can say it is a 0. If it is getting 1, then it is a 1, like that. So you can do this problem as a for your practice purpose. Still, not only this, some more problems also I added here, and you can practice that later point of time. Now you have any doubt, you can ask me, otherwise you can leave. Anybody? You don't have doubts, you can leave.